let's look at integration by substitution. This is a little difficult because it's the chain rule backwards. Do you remember the chain rule? Remember the chain rule is we had the derivative of an inside and the derivative of the outside. And if you remember when we were doing this, I said, you know those students that went over to the side and did all this and then took the derivative, and I said they'll typically do better because they broke everything down in pieces. If you were lazy like me and you just kind of did it by looking at it, it might take a little bit more looking at that. Remember, we have an outside and we have an inside. When we take derivatives, we had a product, right? We had the product of the outside times the product of the inside. So when we end up with a function that has this form, then its antiderivative is this composite function. So to make a substitution, typically what we do is we say let u, or just some variable, be the inside function, and then we take the derivative of du, okay, to match the outside function. So we hope that it matches, and as we're going to see, sometimes we have to mess around to manipulate it to get it to match, and then we express everything in terms of u to make it easier. Just as we did with the chain rule, the inside, when I say the inside function, is still typically inside parentheses, under a radical, under a square root, in the exponent, could even be in the denominator. So let's just kind of review. Do you remember how to do the chain rule? So the chain rule, once again, is we said, so let's kind of do it the way those of you that were doing this over to the side, where you were saying let u equal what we call the inside, or in this case the exponent, and then we said let y equal e to the u, and then we took the derivative of both sides. So the derivative of e to the u is e to the u, the derivative of x squared is 2x, and then we put these together by multiplication, and then finally, and I'm going to write the 2x first, we substituted back what u was. So hopefully that's a review. You remember that, right? That we took the derivative of the inside, in this case the exponent, and then multiplied it by the derivative of the outside. So if you did it this way, the breakdown, you'll kind of see why this works with the substitution. So substitution now says I want to find this antiderivative. So with substitution, what we do, we substitute over on the side and we say let u equal our inside function, and we're going to still call it the x squared. Okay, so that's my inside function, and then take the derivative with respect to x of x squared, which is 2x, and then notice I can multiply both sides by dx and cancel this, and I get du equals 2x dx. So if you notice, what's happening over here is this piece now becomes e to the u. This piece I put in terms of u because it's with the antiderivative with respect to u. Well, notice that's all this, so I substitute du. Now it's easy to find the antiderivative of e to the u because it's just e to the u, of course, plus c. And then finally, your last step is you plug back in what you substituted for u. So as you can see from working it backwards, what I did first when I found the derivative using the chain rule, that's what we're doing over here, is now we're having to undo it because we have these two pieces that were based on, remember this is the derivative and we're finding the antiderivative, which is what we found. So I know in the beginning this is like, what? You'll have to go through quite a few examples and you'll kind of start to notice the patterns. So let's do a couple of more examples. Here I see that, I see that my inside is going to be what is actually inside the parentheses. So I'm going to call that u. So over here, u equals x squared plus 1. I'm going to do the same thing. I'm going to take the derivative with respect to x, which is 2x, and then I'm going to move the dx to the other side. All right, and as you can see, that's definitely, I can substitute that for du, so I get u to the 5th du. I take the antiderivative. The antiderivative is where you're doing that plus 1, so I get u to the 6 over 6, and then finally I just don't forget to substitute back in my u, and I get my final answer. Once again, if you took the derivative of this, you get that back. All right, so let's look at another one. And you're probably starting to see, well, do all these always have 2x dx? No, I just want you to get the pattern down is why I picked the same value for all of these. So here looks like my denominator would be my u. U equals x squared plus 4. We already know we're going to take the derivative, which is going to be 2x, and I'm just going to go ahead and move the dx over. So that's du. Thus the antiderivative becomes 1 over u du. The antiderivative of 1 over u, you remember ln of u. And then finally we plug back in our u to get our final answer. Okay, so again, look at this. If I want to take the derivative of ln of anything is 1 over the anything times the derivative of the anything, of the inside. And so what we're doing here with this substitution, it's allowing us to come up with a way to, I don't know how to take that antiderivative, that's way too hard, but to come up with a way to make this better and easier to find antiderivatives by substitution, and then just don't forget to substitute back. So we'll continue on with more examples in my next video.